Ladies and gentlemen, today I'd like to talk about heap building. Why? Well, I was cramming for my algorithms exam and it took me hours to figure out what heap building was and the different ways to go about it. And as it turns out, it's an incredibly simple concept. So today I want to give you a concise and hopefully an intuitive tutorial on heap building. The first part will be the actual process, and then the second part will be getting the intuition or getting your head around the complexity of it. If you only need to know the process for your exam or something, then just tune out for the second part. But I think being able to know the complexity and where the complexity comes from will give you a really good grasp on the whole thing. And the complexity is pretty simple as well. So let's start out with a heap. What is a heap? A heap is simply a tree which satisfies one of the conditions. Today we're going to be building a min heap, so that means that the lowest the lowest element in our string, in our list here, is going to be the root of the heap. So it's going to be at the top of the heap. So if we recall the heap condition being that all the children must be greater than all the children must be greater than the parents. And the way I like to think about it is that all the parents must be, so parent nodes must be less than its children. So something like 1, 5, 7. Also today I want to be using left to right, so the left one here is going to be lower than the right one. So you can think of it like that, I suppose. That is all it needs to be, is that at any given point on a tree, if it satisfies this, then it's a heap. So heap condition. Hope you guys can read that. Alright, so building a heap. There's two methods to building a heap given a linear input. The first way we think about this, so pretend this is going to be like an exam question, and the exam question could either be build a heap either using top down or bottom up, or it could just be build a heap using the most efficient way. Now, hint, the best way to build a heap, the most efficient way to build a heap is bottom up heaping in every case. Top down heaping is simply just going from here and then inserting every node afterwards. So going so inserting 1 and then inserting 9, and the way you insert is that you add it to the very end of the tree and then you upheap until it works. That's it. And that turns out to be a pretty horrendous complexity. So top down complexity works out to be O of n log n, and as I said, we'll get back to this later on to determine where this comes from. Now the other way is top down, which is the bottom up, which is the way that I'll be teaching you today. Because it is just so much more efficient, it should really be the only one that you will be practicing, and it is incredibly easy. So we go, and its complexity is much better, and you might not believe it, but that's its complexity, O of n. We'll get into why it's O of n a little bit later on, but for now that works pretty well. So let's get into it. So as you see here, we have a linear array of input. Now the way that we want to do this is take our array and treat it as a heap already, or at least we can treat it as a heap already that hasn't been sorted so that it satisfies the heap condition. That'll be fine. So the way that you do this is that at any given point in the array, you can think of its children as being the index of that point times 2 plus 1 for its left child and plus 2 for its right child. So you can think of, so the children of 1 are going to be 9 and 7. The children of 9 are going to be 15 and 22. The children of 7 is only going to be 1, and that's going to be 11. It's only going to have one child, which is 11. Now you can keep it as a linear array while you're doing this. I would strongly recommend you do not do this, just draw out a heap while you're doing it. All you want to do is draw it up so that you don't stuff up, you don't lose marks just based on a simple indexing, basic addition or multiplication, just because you're under pressure or something like that. So let's do that. So the way that we draw up a heap is that we just go top to bottom, left to right sort of thing. So this one, so 1 is going to be our root node. Actually, I'm gonna mix it up. So let's go bang, bang. So now this is 9 and this is 1. Just I like it better like that. So we'll go 9, 1, 7, 15, 22, and 11. Bang. Nice and easy. Now from here, you shouldn't be asked to draw every single step of workings. If it does, then it should be like a massive marks question, because you'll be drawing it out, like depending on what input you have, you can do it for as many as you want. Also, if your question, or if you want to build a max heap, you should be fine. You should be able to follow along this tutorial, no worries at all. All you got to do is flip this sign. So that's a heap condition, that's min heap condition. You should be fine. Just do every swap that I do, just do the opposite basically. Alright, now we have our heap here, but it doesn't actually work because, as you can see, 9 is not less than 1. What we have to do is a process known as upheaping. So we just perform rotations on this tree. So we start from the top. We say, okay, is 9 less than all of its children? No, no. What we do, and this is important, very important, so you need to pick the lowest of its children and you switch it with the lowest of its children. This just makes your life so much easier, and it is how it should be coded up if you're going to write it in Python or something. So we pick the lowest out of 9's 2 children, which is 1. Now, if you do need to write out every single step, write out the whole tree, I think it's useless. Just do it in place. So just scratch that one out. Go 1 and 9. Bang. And then you have to follow the node that you just switched out. So we follow the 9, like, okay, is 9 less than all of its children? Yes, it is. This is actually a pretty terrible example. Yeah, and then as it works out, this is a heap. This is sorted. You just need to perform that one rotation. Now let's do a little bit more of a tricky one, hey? So let's start out with 8, 3, 2, -5, 18. One. Alright, so let's do it again for all of this, shall we? So we start from the top here. 8, is it less than either of its children? No. So what we do, we switch out the 2 and we put it in place for the 8. Now we have to follow the 8 and be like, okay, is 8 still less than all of its children? No, because 1 is less than 8. So we switch them out. So we go 1 and we go 8. And we're cool. Now we look at the other side of the tree. Okay, is 3 less than, so is 2 less than all of its children? Yes. Is 3 less than all of its children? No, because -5 isn't there. Isn't less than that, so all we do is switch it out. Greater than, yep. Yeah, and so now we look at it again, and we're like, okay, is this heap satisfied? No, obviously not. -5 is still less than 2. So, very easy, we just switch it out. Bang. Bang. Too easy. That is done. And I did that in, what does it say there? 9 minutes? Yeah, right. 9 minutes. That was 9 minutes for two of those. This is normally about a 4 mark question in a 120 mark exam for 2 hours. So that was me explaining everything. This is just one of those questions where you can really punch it out. It is super, super simple, provided you draw it out. It doesn't matter how big the tree gets or whether they want to use characters instead. I hate it when they use characters. But I always have to draw out the alphabet at the top. But it's that easy, guys. So the second part we'll be talking about today is... Alright, last thing I wanted to talk about today, guys. Everything I do here isn't for profit. I don't use this as any sort of a means for employment or anything like that. I use it just so that I'm able to improve my ability to teach and to hopefully get some people engaged in computer science, because it's pretty awesome shit. I really like it. And so with that, let me know if you found this to be really cool. Let me know if you liked it. Let me know if you learned from this one. Let me know if this really clarified something that your teachers just couldn't. On the other side, though, let me know if it was shit. Like, if it was terrible, if it was horrible, if you were just like, that was just painful to sit through, and I learnt nothing, then tell me about it in the comments. Fire me an email, you can see on the homepage as well. Just tell me about it. I want to learn, I want to improve. But if you did like this style, let me know what sort of videos you want to see in the future. I'll be doing everything from basics of Python to some of the simple AI stuff and everything in between. So if you want something clarified, just let me know. I might even be able to answer it to you directly, or I'll just create a new tutorial. With that being said, guys, I'll see you at the next one.